In this problem, I'm given an actual equation of a function, and I'm told to find all the values of x for which the function is differentiable. Well, I would start by graphing it. And just as a little bit of calculator review, you can push the math button, and item number 4 is a cube root function. So I can go cube root 3x minus 6 and close my parentheses. Personally, I prefer to, when I have anything other than a square root, to use fractional exponents, because I don't like, if it's a 4th root or a 5th root, it's a real hassle to use this math button. So I prefer to just go parentheses 3x minus 6, close parentheses, caret, and I'm taking it to the 1/3 power, so 1 divided by 3. Now, that's not 0.33, because that is not the exact number of 1/3. So I put it to the 1/3 power, and then I'm going to go plus 5, and I'm going to go zoom 6, and I'm going to graph it, and there's my graph. And I don't know, I can't really tell a lot about it from the graph, but looking at it, I am reminded that the graph of the parent function, the cube root of x, looks like this. And I remember that in this area right here at 0, there is the slope is vertical. And one way that I remember this is because I know that the graph of x cubed, which looks like this, at the origin has a slope of 0, horizontal slope. And since the cube root of x is the inverse of x cubed, the horizontal is going to become a vertical. So I'm remembering now that in a cube root function, it's likely that I'm going to have a vertical asymptote for the slope. Not an asymptote, it's a vertical slope. Well, so now I have to find out what x value does that vertical slope occur. Well, I'm going to think about this in terms of transformations. So I know that my standard transformation is I have an a times some function f, and a b times x minus h plus k. This is a vertical stretch or compression. This is a horizontal stretch or compression. This is a horizontal shift left or right. This is a vertical shift up or down. How can I make the function that I am given right here look like in this form? Well, the one thing I notice here is that my x in my template for transformation has a coefficient of 1, or you could say it doesn't have a coefficient. Okay. So here, though, I have a coefficient of 3. So this is really h of x is equal to the cube root of 3 times x minus 2 plus 5. So I can see now that I have a horizontal shift of 2. I have a vertical shift of 5. I have a horizontal compression of 1/3, 1 over b, but I'm not really concerned with that. This is really what I'm concerned about, was that shift. So as where my parent function of the cube root of x used to cross at the origin, now I've shifted it 2 to the right, and I've also shifted it up. So that is where my my vertical slope is probably occurring. I cannot differentiate if I have a vertical slope. It is not differentiable there. So I am hypothesizing that at x equals 2, this function is not differentiable. And I think I come over here to take a closer look at my graph. I'll try changing my window. And I'm going to change my window. I'm going to go from 1 in the x value to 3 on the x value. And since I've shifted it up 5, I think I'll go with my x minimum to be like from 3 to 6. So I'm kind of zooming in on that one portion of the graph, and let's see if we can see what it looks like. Well, here it comes. And sure enough, I have a vertical slope right there at x equals 2. So to answer the question properly, find all values of x for which the function is differentiable, then the answer to that, written in interval notation, would be, well, it's differentiable from negative infinity all the way to 2. And then I have to skip over 2, and it's differentiable every place else from 2 to infinity.